Okay, let's go through and do some examples now. So what I recommend you do is if you see a plus or minus sign, just treat each part as a separate thing. So treat the x squared as separate from the 5x, as separate from the 3, and then eventually we'll get good enough that we can go through and do them real quickly, just like you guys are good at applying power rule to more complex derivatives. So start off by writing big F of x is equal to, and then you have to think, well, what is 2 plus 1? It's 3. So you do 1 over 3, and then do x to the 2 plus 1, which is 3. So there's your first term. And then do plus 5, and then remember your n value here is 1. So what's 1 plus 1? Well, it's 2. So I do 5 times 1/2 x squared. And then I do minus 3, and then I just put an x because it's a constant, and then put my plus c. So now that we got that, this is a little bit of a mess. Let's make it look nicer. So generally these are written in this format, is equal to x to the third over 3 plus 5x squared over 2 minus 3x plus c. They're really the same thing, but it's whatever. Okay, next problem. So it says find the antiderivative of 2x to the third minus 6e to the x plus pi. So do the same thing as last time, break it apart, look at it individually. So we got big F of x is equal to 2 times, so think what is n plus 1? Well, 3 plus 1 is 4, so 1 over 4 times x to the fourth, and then I do minus 6. What's the antiderivative of e to the x? It's just e to the x, and then plus pi. Pi is a constant, so it's plus pi x, and then we do a plus c. So notice how each time I've been writing my constants in front, I've just been rewriting them. I haven't been worried about them at all, and that's because of one of our properties, where if you have a constant, you can pull it out and put it out in front, and it doesn't matter anymore. Okay, so simplify this. You get x to the fourth over 2 minus 6 e to the x plus pi x plus c. And this is our antiderivative. Okay. Next problem is find the antiderivative of the square root of x minus the cubed root of x. So let's rewrite this into our fractional exponents real quick. This is x to the 1/2 minus x to the 1/3. Okay, so now you have to add fractions, which I know everyone is really great at. So let's write down what our antiderivative is. Okay, so you're just using backwards power rule here. So what is 1/2 plus 1? Well, 1/2 plus 1 is 3/2. So you got 1 over 3/2 times x to the 3/2. And then what is 1/3 plus 3/3? It's 4/3. So I got minus 1 over 4/3 times x to the 4/3. Okay, and we can rewrite this to make more sense. This is big F of x is equal to 2 over 3 x to the 3/2 minus 3 over 4 x to the 4/3. And what's really cool is if you look at it and really think, well, if I were to do power rule to this function here and figure out what my derivative is, I'm going to bring down this 3/2 and do 3/2 times 2/3, and that's just going to be 1. So it goes away, and then I do 3/2 minus 1 to get my new exponent, and it's just 1/2. So that's where that comes from. It's kind of nice, and you can kind of go backwards and think about it that way. There's a lot of quick ways to do this, but you always have that backwards power rule to kind of rely on.